So the question was to find the picture of this equation, and I guess using analogy with our parabolas that we were graphing before. If I isolate unknown y here, so I put a quarter multiplied by x squared, like that. So y is equal to 1/4 x squared means we had parabola that is wider, right? And opens upwards somehow like that. But in the case if we switch x with y, then we should actually switch the parabola to open along not positive direction of y-axis, but along positive direction of x-axis, which is going to be also wider parabola, but going to the right because its analog here was opening upwards along positive direction of y, so we go along positive direction of x-axis, and 16 looks like is the answer, so that's the one that we should have for the quiz. And actually they gave you a good hint here where x is equal to 1 and y is equal to 2. So if you were to replace instead of x number 1 and instead of y number 2, you would definitely get a true statement that double checks and verifies that indeed the exercise is done correctly. So we worked with parabolas, and that was a refresher of what you learned before. And if not, that's fine. We can just do another problem or so from this section. So we move to the next part of the story that deals with so-called ellipse. That's the figure that they have here for us in the picture number 19. And what's remarkable about this ellipse thing is that it has two special points, focus points, they call them foci. So two points that sit still, and the figure produced by using, let's say, some kind of thread, and if you put a pencil in it and then start to rotate, then the actual figure will have, the actual pencil will draw this ellipse for you. The sum of the distances from the point on the ellipse to the foci will stay the same. That's the idea of how they produce this figure. So any point on the figure, if you connect it with foci, will give you the same sum of one piece and the other piece in here, which is interesting, but I don't think we're gonna really use this much. But you can see that this figure has equation that contains both and x squared and y squared. And in order to produce this picture, what I need is to get a here to the left and to the right, and b upwards and downwards. And this way we can draw this like a squeezed circle that is called as ellipse. So what's important to have is so-called center, and the center of this is always called as H and K, so the pair H and K, just like in the case of parabola we had. And then if we know A and B, then we'll be able to produce the picture. So the actual formula is x minus h squared in the parentheses, and also y minus k in the parentheses, also squared. And this is divided by a to the second, and the y part is divided by b to the second. And the sum is equal to number 1. So this is the equation, and let me show you this here, where the theorem appears. Actually, let me move on a little farther. I think it's okay. It's here to the on the page 647. So all I want is to practice using this formula to produce the ellipse, and for that matter, all I need is center HK put down on the XY plane, and then we're gonna need to have the coordinates of A and B that are underneath. So I'm going to just take a few exercises here and do them. So skill building part, as usual, is what I concerned with. So let me start with exercise like number 17 in here. In this exercise, we supposed to pull out center and the A with a B for the ellipse. And what I can do is notice that my X and Y, they are clean with squares, so I can write them as minus zeros, because center in this case will be a origin or point with coordinates 0 and 0. And then instead of 25, I can put 5 squared, and instead of number 4, I'll put 2 squared. In other words, if I compare this with my formula, then center of this ellipse will be a pair 0, 0, right? Because we don't subtract anything. And then A will be 5, and B will be number 2. So we can graph it. I put 5 units here to the right, as well as to the left, someplace here. And then 2 units up and down. So this way we get points to connect. I just want to write 2 a little bit nicer. And this way we're gonna produce our ellipse. So somehow like that. In other words, this formula is very helpful and just what I need to produce the figure. So let's try number 21, another recommended exercise here that does not have number 1 on the right side. So my goal is to always produce number 1. So what I'm going to do is get rid of that 16, because we have 4x squared plus y squared is equal to 16. So what I'm gonna need is to put 16 and denominator under each term of this equation. So this produces number 1. That's just what I need. And then y squared, so it'll be y minus 0 squared over 16, which is 4 to the second. And then for x term, I have 2 squared, right, underneath, because 4 is 2 to the second power. So I'm going to write this as 2 squared in here. And now we can see that A is 2 and B is 4. So to produce ellipse with a center again at the point 0, 0, I'm gonna just put this origin here and go to the right by 2 and to the left by up and down, actually, by 4. So somehow like that, and then produce ellipse, which looks like squeezed on the left and the right sides, right? Somehow like that. So this is the picture. Excuse me. So it's
Excuse me.
nice when our ellipses have a center at the origin. That's definitely convenient. So
Excuse
let's,
me, mister.
yes, please.
I'm a little bit confused at where x minus 0, like inside the parentheses. I don't understand why you have 2 squared there.
So question is why this is 2 squared?
Yeah, why is that 2 squared?
Well, because I can write number 4 as a perfect square. My formula here wants me to have perfect squares.
Well, before it's because I was looking at the other one and you divided that one and you got it to 4 squared. But for this 16, you broke it down and then you got it to 2 squared.
So I canceled 4 and 16, so that was 4. Right?
Uh-huh.
4, and instead of 4, I
Oh,
can put 2 squared.
that's
And
where I was a little confused. I didn't understand what you were doing.
okay, so now it's
Yeah, I get you.
okay. So let's do
Thank
one
you.
more. How about 22? So it looks like with 22, we have 18. So I'm gonna divide by 18. And this way I'm gonna start to produce number 1 on the right side. So if you have x squared and 9y squared is equal to 18. So what I do is produce 1. So that's the first step. Always same thing. We need to produce number 1. And the way to produce 1 from 18 is divide by this same number 18 left and the right sides of my equation. So I divided by this, whatever we have on the right side, by that number we divide entire equation. So that doesn't change it, but it produces 1, and that's what I need. Now, x squared, so I can write it as x minus 0, just to make sure that we can see what the center is. And now, how can I write a perfect square instead of 18? Well, we square root it, and we put square. Because square root and square, they leave us with the same exact thing. So with that number 18, so I just extract the square root and then put a perfect square. Looks like I cannot square root 18, so I just leave it as a radical 8. And this is going to be my a, which is squared. And analogously with the second piece, with y, I can also treat it as if it was y minus 0 squared, and then it's 2, so I put a square root and also square. And this is going to be another number, b. So if we can't extract the square root, that's fine. We just leave it as a radical, and square root 2 will be going up and down, whatever it is, 1.4 or something. And then square root 18 to the left and to the right. Square root 18. So we have a way to deal with any number whatsoever, and this way we produce our ellipse. And again, the center is at the origin at point 0, 0, which is not always the case. So we can actually take a look at the next group of exercises where we not going to have such a nice looking equation where we have just a clean x and y's squared, but there'll be some other numbers involved. So in the next group of problems, we'll have ellipses that actually don't have the center at the point 0, 0. So I can try to do exercise like number 43 with, well, very clearly given us center. Looks like it's x minus 3 in the parentheses squared, which is also divided by 4 that I can write as 2 squared, right? And analogously for the y term that has y plus 1 in the parentheses also squared, denominator is 9, so I can say it's 3 squared. So here my center will be pair 3 and -1, right? Because we always change sign, so this plus I have to put as a negative, and -3, so I get 3. And then we can also see that a is equal to 2, and also b is number 3. So point with coordinates 3 and -1. So let me actually try to put this in the picture a little bit nicer. So 3 and -1 will be my center. And then I need to go up and down by 3. So probably someplace here and there. I'll get my b, right? So that's numbers we go up and down by, and then 2. So it's a little less. So it's somewhere here and here, right? That's going to be 2 for a. So here's my ellipse that corresponds to this equation. So I'm trying to do my best to make a picture. It's kind of hard, but well, just try. It's not always that nice, though. It's not always in the form that we have here. It's our equation. So let's say exercise like number 46. We should produce number 1 on the right side. So this has 9 times x minus 3 in the parentheses squared, and also y plus 2. So we nicely given a center, looks like it's going to be 3 and -2, right? So we change signs in the parentheses, but first of all, we need to get rid of that number 18. And to do this, we already know division by 18 is needed, right? So I divide by 18 because my first step is always to produce number 1. And then see what else remains here. So looks like x minus 3 in the parentheses squared will be divided by 2. And I can write it as a square root 2 and square. This trick of squaring and extracting square root is actually standard in the section. Plus 2 is y squared. And we rewrite 18 again as a square root 18 and then also squared. And this way I can see what a and b supposed to be equal to, right? A always under x and b is always under y. So to graph this ellipse, I'm going to use center, which is nicely given to us as a pair 3 and -2, right? We can see these numbers here. So change signs in the parentheses as usual. So 3 and -2 is someplace here. And now I need to imagine what a is supposed to be. So square root 2. Well, square root 2 is about 1.4 something. So when I go to the left and to the right by 1.4 from level of 3, I'm not going to touch my axis, my y-axis, because it's not far enough. And then square root 18. So if I square root number 9, it's 3. And that tells me that probably we're a little bit higher than the x-axis, somehow like that. And then I'm going to connect this with ellipse-like curve. So produce this, something like that, right? So I would say this is another nice exercise, even though they start to get more involved with various numbers here because of giving us center different than 0.00. So let me try now something not as nice. Let's say exercise 53 that has also ellipse, but it needs a little bit of a preparation, just like we did before with circles. So what bothers me is having plus 4y in this little equation, because this way I need to figure out what is the center of ellipse. So I need to take this number 4 and complete square on it. Remember, I used to divide it by 2, right? So if I divide 4 by 2, I get 2 squared. I add it. And also I subtracted. So I add and subtract 2 squared, which is 4, because this is how we used to complete the squares. So we put a first term y squared as y, last term 2 squared as a 2 in the parentheses, and the sign will be plus because everything is positive. So we have it squared, and then -4 will remain. And also I copy 4x squared just the way it is. So I just completed the square like we did previously. So we need not to have 4y term here, but parentheses. Clean this, it put too much mess. So what we had to do is, as usual, number 4, which is multiplied by y, was divided by 2. That's how I produced 2, and then squared it. And then I added and subtracted the same thing, so equation did not get changed. Now what? Well, this number -4 needs to be brought to the other side. because just x's and y's squared have to be on the left side. So my y plus 2 to the second power is here. And then, just like in the previous exercise, I need to produce 1. And this way we have to divide by 4 each piece in our equation. So this nicely cancels. And we got 1, and that's just what I needed. And now it's x squared, so I can treat it as if it was x minus 0 squared. And then it's not divided by anything, so I can say it's divided by 1 or 1 squared. And the other piece is y plus 2, so I can say it's going to be also divided by 4, which is 2 squared. And we are able to pull out our a and b this way, and also to say that center of this ellipse is going to be pair 0 for x and -2 for y. And once you have pulled out this center of ellipse, then everything is fine, because now you can make a picture of it. I guess I'm not going to graph it because we already graphed so many ellipses today, so I'll let you do it if you want to. But the point of story, we need to have a center, and that's what we were able to produce when completed square. And also whatever is underneath x and y's, a and b, that will help us to graph. Let me do one more. Here's 47, another completing square exercise that I will try to do. In fact, we need to complete square 2 times in here. So we have x squared plus 4x. I'm gonna keep it separately because I need to add and subtract some stuff. And also with y's, I'm gonna have to put here 4y squared minus, actually, let me not hurry, let me just copy this whole thing. So plus 4y squared and minus 8y. And then finally, there is number plus 4 at the end, and this is equal to 0. So the problem here is with y part, because we usually have a clean square term, but 4 is on the way. So I'm going to need to take out that 4 and factor it from y squared, and then also divide by 4 my -8, so it'll be minus 2y. And then there's still going to be plus 4 is equal to 0. So I'm preparing a little room to complete the square, and also factored out 4. And also, similarly to the first part, I'm going to write this x squared plus 4x a little bit away, so I can start to divide by 2. Remember, we always want to divide by 2 in order to complete square, just like in the previous problem. So I'm going to divide 4 by 2 and get 2 squared. Add and then subtract. And of course, this is plus sign. So notice that we added and subtracted number 4. And some people can say, Alex, plus 4 and here's minus 4. They can be canceled right away. Okay, so cancel it so it doesn't stay on your way. And similarly with y part, I also divide by 2. And when I divide 2 by 2, it's 1. So I'm going to add and subtract number 1 squared, which is just 1. So when we completed square, we can write what we were supposed to, which is going to be a perfect square inside the parentheses. And it's x here, and then plus 2 next to it. So the first term, x squared, gives me x, and last term, 2 squared, gives me number 2. And then I just copy that 4 in front of the parentheses, and inside of that parentheses, we also have a perfect square. So let me maybe use another color here. So these 3 terms with y have y and minus 1, right? Minus because of this negative. And then there is still minus 1 waiting for us. And this whole thing is equal to 0. So 2 squares were completed in order to get coordinates of center of this ellipse. So I'm going to copy this equation, and I'm going to need to distribute 4 now backwards because I don't need this extra parentheses. I just used it to help me to complete my squares. So I multiply by 4 and y minus 1 to the second, and I multiply by 4 negative 1. So it'll be minus 4 is equal to 0. So little by little, we produce our goal equation of ellipse, and we already can see what center is, right? Minus 2 and 1. But now I need to bring that negative 4 over to the right side. So I'm changing its sign, right? I get x plus 2 squared in the parentheses and plus 4 times that y minus 1 squared. And then we'll divide by 4. So it looks like the process is, yes, tedious, but I guess we just follow pretty much same steps in this exercise as we did before. So now my goal is to produce number 1 on the right side, as we have it in the equation for the ellipse on the right side. And then we'll be able to see what A and B are, and also write down the coordinates of center. So this is going to be 2 squared underneath here. And for the other piece, 4 and 4 will cancel, so we just have 1 on the bottom, so it'd be 1 squared. And this is y minus 1 to the second power. So our center for the ellipse is pair negative 2 and positive 1. And also I can see what A is. It's 2 under x term, and under y term is B. It's equal to 1. And then we can make a picture of ellipse. In fact, why don't I grab one? And I think that should be enough for today, because I know there's just too much of this ellipse.
Professor,
Yes.
where did you get the 4 that you moved to the other side?
Number 4 was produced by distributing this 4 outside the parentheses over y minus 1, and then negative 1 times 4 was negative 4. So
Oh, okay. Thank
I
you.
brought. Sure. Yeah, that's very good that you follow these little details. I would actually recommend that try to do the same exercise 47 before Wednesday, because when I do this, it seemed to be straightforward, but there are indeed lots of little details that so easy to miss. And I think if you just do one exercise like that, that should be good enough, because they're all pretty much same problems, the same process, but it is a lengthy process to follow to produce these equations. There are lots of little steps. So I'm glad that you are actually looking at these. That's a very good question. So let me put center, negative 2 and positive 1 someplace here. And then I need A and B, right? So I need to get this A, which is 2. So I'm going by 2 units to the left and to the right. So I will touch my axis, and B is equal to 1. So notice that it's going to be also touching the axis. So when I graph this ellipse, it'll be sitting nicely in this corner, somehow like that. It's like a football, you put it in the corner, so it sits here. So I don't think I'm going to give you a quiz today. These problems are on tedious side. We'll do more of these exercises on Wednesday. So it'd be good if you found the time before Wednesday and try to do the same exercise again. Because technically, if you know how to do 47, then you know how to do all problems in this section, as well as in the next section. Next section is going to do exact same process, but to graph some other curve called hyperbola. So we're going to also use same exact series of steps in order to produce those graphs. So I'm not giving you a quiz today. We had one last time. I was pretty happy with results. Pretty much everyone did it correctly. If you did not take the quiz, take it. Email me the answer. I will gladly accept it. We were graphing parabola. Actually, you can check a recording of the lecture that I emailed to you last Friday. So I guess that's pretty much all for today. I'll let you go and enjoy the rest of beautiful Monday. And if you have any questions, please let me know.
Thank you.